We are in here in chapter 15 in Advanced Engineering Mathematics Review. In chapter 15 is covered the curves and surfaces and the volumes. As introductions give the 15.2 the curves and line integrals. You see in these pages is explain the curves and the line integrals. And when we continue inside of the chapter 15, this line integrals and basic mathematical definitions and important concepts. This exercise part and section 15.3 is give us the double and triple integrals. We are familiar with the double integral. Is give the area and Riemann sum on and the theorems, and especially the very important theorem is the mean value theorem. According to the mean value theorem, when we apply the double integral, we obtain this area of the R in the space. This gives us the dA, double integral of the dA. So when we continue, we in examples, and we are here on the section 15.2.3.2 triple integrals. Similar the double integral is give in R. We represent by this formula, and so the application of the mean value theorem in the double triple integral in R, we obtain the volume of R by this formula, and this is the example of the triple integrals. So this is the exercise part. Section 14.4 is give the inside of the surfaces. So parametric presentation of the surfaces. So you see here what surface was definition of surface in Cartesian coordinates and spherical and cylindrical coordinates. In here, section 15.4.2, it's give tangent plane and the normal. It's give the definition of the normal. A normal is the is perpendicular the surface of the body, called is normal. Let's give the definition of normal in tangent plane. So okay, again increase our speed. Come here, section 15.5 is surface integrals. This is the part of the surface integrals. In here, just continue the surface integrals. And we just go another section. Section is 15.6, the volumes and the volume integrals. Actually, this is these are the important concepts. And when we go, the transport phenomena is happening inside of any system. To understand the physical meanings of the physical meanings of the transport phenomena, transport events, we should know all this concept, all these things, to understand very well what are the physical meanings of each concept inside of the transport phenomena. So we just finish the chapter 15 here, and we go to chapter 16 in scalar and vector field theory, like introduction, we see this is the kind of PD. You see dependent on X, Y, Z, and T. The concentration to C, we can call C, not call concentration. Okay. Okay, now we go after introduction, the divergence. Let's say we have, actually I want to just stop here and go more deeply. The fundamental scalar and vector field theory are certain differential operators known as a divergence, gradients, and curl. They operate on these fields. These three concepts in here, they actually operate on these fields, vector fields. You see the any control volume. Uh, in here, let's VB vector field defined in the region R. Physical nature of the V is the material here, but for definiteness, let us think of V as a fluid velocity field. Think about the fluid velocity. So focusing our attention on a particular point, let's say any point in the R control volume, let's say P, is the position respect to X, Y, Z in the flow, in the velocity flow, in the velocity. Let us introduce the control volume around the P. Let's say we have around P, we have this any control volume. So when we go, starting from this equation, from this integral, when we go here, there's some mathematical manipulation give us this result. We call it the divergence of V at P, is defined as following. And we can express this equation more open. Let's say the divergence of the V on the point P is given by this equation, partial derivative of the Vx respect to x, Vy respect to y, Vz, and first derivative, partial derivative to z. We call this definition is divergence, and this del operator, differential operator, is represented by this formula, and we can call this partial derivative dx, d over dx, d over dy plus d over dz. In here, rjk is represent the index notations on the vector fields. Then we can reduce this form to this forms briefly, because this coming from the del vector operator, the differential operator. So later we are gonna go over again these concepts more deeply. Now I just briefly introduce you. So now I come here. Okay. So gradient, another concept. Uh, so it is physical significance. We call use the gradient of u, or grad u, or we call del, or operator cross product of v, the curl of the v. So okay, now I just briefly introduce. Okay, divergence of the v. V is uh, the velocity on the any vector field, and we represent the divergence by this formula. We call this del operator again. So input is the vector field v, and output is this mathematical tool is output is we call the scalar field. We obtain scalar. Grad u will represent by this formula, and we input is the scalar field, like u this time, not the vector field. and we obtain the vector field like this. And the curl is the input is the vector field V, and cross product is give you again vector field. So these are the three basic concept and definition, and we can represent grad U like this and or like this. So as we continue, we just reach the section 16.5 is explain the curl. Curl is the we represent like this, and again we continue. We reach the section point 16. Sorry, we can go back. Okay, in here reach the section 16.6 as the combination Laplacian, and section 16.7 is given on Cartesian system, divergence, gradients, and curl and Laplacian is optional topic. You can find many useful knowledge from here. So section 16.8 is give you divergence theorems like this. We are going to use this divergence theorem is very important in the derivation of the transport conservative laws, and when we use the Reynolds transport theorem, we are going to use also divergence theorem. We are going to come back this later. Okay. Basically, why I'm doing this, I'm just gonna mention going over all these chapters and the section inside of the chapters. Just remind myself and you what you can find in this book, and it's actually good things for the students, especially for the professional, for the grad students, because when they doing their master or their doctorate, they will encounter many problems in their research area, research topic. So when they see some problem, they can come back and they can read and find their solution, and they can get also a deep idea from all these topics. So it is not possible to know everything or memorize everything. I think it is very good idea to know very well the book you use, like a Bible, for example. You need to know every chapter, what chapters cover what, and which information you can find where, in which chapter, in which section. That's why I just go over, and it takes some time, but again, I think it is useful. Later, I will appreciate this, and you will understand why I'm doing this, to just know what is where. Important point. So let's continue. Just another this exercise here. Oh, okay. Another important topic is the Stokes theorem. It's give here the Stokes theorem. Okay. Now basically this is the result of all the Stokes theorem. This give us what's the Stokes theorem give us, and we will use also this in the derivation of conservation laws in later the class. Okay. Another theorem is the Green's theorem. We are gonna also use this theorem in later. So section is 16.10 is irrotational field. Another topic here. So review of the chapter 16. The chapter 16 is define the divergence of the vector field V as following. From here, the results get the divergence of the vector field V like this. Then it's defined the del operator here, the differential operator, another name. So divergence of the V by taking this can be defined like this. Then it's define the gradients of the scalar like this, and the curl of the vector field V as a cross section by del operator or differential operator by the vector V, and so on. Second order Laplace operator, we call this with the del operator, and divergence curl V like this, curl grad U, and so fundamental theorems and Stokes theorem, divergence theorem, and Green's theorem, so on. This chapter is very important to give many important theorems. We utilize the derivation of the conservation laws. So chapter 17 is give the Fourier series and Fourier integral and Fourier transform. We use the for, we will see all these names later in the transfer phenomena book. So I just skip this quickly, and I just want to go reach this chapter 18 to conclude my review of this book. So we are here in chapter 18. Chapter 18 is give us the deep inside of the diffusion equations. So you know the introduction diffusion equations, and for heat transfer, mass transfer, and momentum transfer, they are analogy each other. Basic concepts it's give us. It's give us some solutions of the diffusion equations. We will come back this chapter again later. So this book has also another uh, chapters like chapter 19, chapter 20, chapter 21, chapter 22, chapter 23, and chapter 24. But I just want to stop here. I think this review now is enough. So what I did, basically, what was my purpose by doing this review, to go over, and I recommend you this book, Advanced Engineering Mathematics, for especially for grad students, to get the basic knowledge and deep understanding of the mathematical concepts beyond all these things we are gonna see in the transfer phenomena. So you can get all the almost necessary information, mathematical backgrounds from this book. And I hope see you in the next video. So in the next video, we are gonna go to review of the or basic tensor and vector analysis to start the chapters in the transfer phenomena second edition. See you in the next video.